Hello there, and what we're going to do today is I'm going to do a demonstration on how to populate the 8051 development board. This is the Revision 2 board, and the Revision 3 is pretty much the same board with some very trivial changes mechanically and won't affect anything for the purpose of this video. So first, let's start off with the easy things, such as tools. So what do I need? Well, I'm going to need a soldering iron, and to keep the amount of flux, fumes, and so forth, I've got this little fan set up to kind of take air away from me so it doesn't get up my nose. Very inconvenient. And some cutters. These are some flush cutters. You can use the side cutters if you wish, and a pair of pliers to bend things, a pair of wire strippers, solder. This happens to be the world's finest solder. Mind you, it was also probably 1970 when that was marked as such. A pair of tweezers for the handful of surface mount things. Optionally, I've got a plunger and some solder braid. The last of my solder braid, unfortunately. So, and of course the most important thing is the documentation, because hey, how are you going to know what you're doing? So the documentation is simply the schematic, and then I've got very zoomed in a blow up of the silk screen on the board. So this is the top side, as you can see here, front, and shows the reference designators and values for most of these parts as well. And then I've done the same thing for the back, and you can see there's not a whole lot of parts on the back of this board, but you can't see this on the there is no silk screen on the back of this board, so you kind of need this to do this job properly. So there's my reference. Now I'm going to start with populating the back side of this board, just so you're aware. And I've got these little blue markers, so as I do this, I can put the board back in a centered position, so when I work I don't slide it off and it doesn't wander off over here and you can't see anything. So those are just there so I can give you a reasonable looking picture. So I'm going to turn my iron on, and as you can see it's warming up, and when it starts blinking it'll be good to go. Now as far as the sponge goes, I want to have the sponge moist, oops, and you can see, and then I have the tip, and you can just wipe the tip off for the corrosion. And the idea is you can tin the tip when you actually aren't using it, and you have a little bit of solder on there so that the tip corrodes, I'm sorry, the solder corrodes and the tip does not. That's the idea there. So, and the fan is there to take the fumes away, as it should. Okay, so let's start with the back side here, and I'm going to start with the 51 ohm resistors, and the 51 ohm resistors live right there, all three of them, so that's real simple. And I'm digging my little bin of bits here, pull these out. Now, but part of the reason I chose to do this little demonstration was I saw a lot of people having issues with construction, and then it would come back later to bite them in the form of, my board doesn't work, oh no, what do I do, help me fix it. And part of my goal is so that I want you to learn how to fix it yourself, really. So here's what you do. I've got tweezers, and I've got my first surface mount bit, and what I'm going to do is I'm going to try and line it up, and I'm going to tack one side and try to get it square. And mind you, this is not perhaps the most elegant solution. I am not a professional solderer. There are people with certifications that know much better and much more effective techniques than what I'm doing. So I tack the one side, and I just need a little bit of solder on the other side, and then I touch up the other one, and that's it. I'll bring it in a little closer so you can see. So, ooh. And it's about the focal point there, so it doesn't look too blurry. But you see, it doesn't look, it looks shiny. That's really what you're shooting for there on as far as a solder joint, and not a gigantic blob is the other critical bit. So, oops. And every time you hear that little hissy noise, it means that I've hit it with the sponge. So, again, just enough to get that thing to stick. And just enough, a little much there, but that's okay. To get it to stay put. And I can always touch these up after I'm done. Mind you, I'm kind of working on a handicap here because I'm doing this behind a camera and not hunched over it like I normally would be. Another thing you can do is I can tin that one pad, flow it, get it squared. And that's really the toughest part. And there, now it's in place. Now I need to make sure I don't apply heat too long, because otherwise it'll flow on the other side again and the heat will transfer. Because remember, you're just touching something that essentially has contact on both sides. So if I heat one side, the heat will eventually go to the other side and flow the solder there. So there, I've done 3 of my parts pretty painlessly there. Now, those are some of the easier ones, because those are the big resistors. So let's do some of the smaller components. These are my 0.1 microfarad caps, and I actually bother when I kit these up to mark them as such, because capacitors aren't labeled at all. They're just this little brown rectangle, and that's it. And these are moderately good size. I think these are 1206s or 1210s. They're the next size up on the 0805 surface mount parts. So I have 3 capacitors, and I look at my reference sheet here, and one goes there, right there, one goes there, and one goes right there, and the other 2 are 1 microfarads. So that's why I need that silk screen, because, or not the silk screen, but this documentation, so I know what I'm doing, because otherwise I'm just putting parts in willy-nilly, and that's just not cool. So let's tin up another pad. And I recommend for the iron, I like these Weller West 51s. If you have another temperature controlled iron that you prefer, go for it. There, I'm actually putting a little too much heat on that part. Go for it. The dumb sticks are kind of my least favorite choices overall, because even though I've got on this board the ground plane is thatched, you can still run into issues where, you know, because essentially the ground plane is a big old hunk of copper, and I'm going to hit that thing with heat, and guess what? Copper is a great heat sink, so it's going to immediately suck that away, and that's how you get really crappy joints on your solder job. So I need to be careful, and a temperature controlled iron will attempt to compensate for that pretty easily. And of course they can get really fancy. I mean, this iron runs now around $100, and you can get irons that are even more amazing, that up into the $800 to $1,000 range. I don't recommend that for personal use. Touch that guy up a little. There we go. You know, but this is, you know, I own one of these for myself, and it is essentially, it's my workhorse. So take it as you will. That's just a personal preference. And you see I'm kind of spinning it around to get a good angle that I can touch it and hold it. Now when I'm done with this, what I'm going to do is I'm going to get all the caps and resistors installed. So I'm going to install these, I'm going to install the 1 microfarads, I'm going to install the last 1K resistor, and that's all the surface mounts I have to deal with. That's the good news. Now what I want to do after that, before I install any more pieces, is I want to get an ohm meter and verify that they're really in there correctly. So that means the resistors are about the right resistance and the capacitors are effectively an open, because if the caps are shorted, this isn't going to work so good. Oops. And that way, if I run into trouble, it's so early in the game that I can fix it, because, and these are the ones, I also mark these with a marker as well. You'll also notice, since all the surface mount things are on the back side, this side is perfectly flat. So it's very easy for me to slide this and spin this around, and it's not tilting because I can put it on a flat surface and it just stays. Otherwise I need to mess with a vise and it just makes my job harder. So there's a reason behind the order I'm building this, not just, oh, I arbitrarily decided to do this first. There's actually a convenience factor associated with it. Or ease of troubleshooting would be a better word of putting it. Again, I apologize for the not so great solder job, because I am kind of reaching to do these. I typically would do a little bit of a better job than this, and if you have an expert that can show you how to do this better, please consult them. I will, it's like I said before, I am not an expert on this particular skill. I know enough to make it work, and for most things that's good enough. Now I got to be careful here, because there's that hole right there. If I don't watch it, I'll plug it like that, and I screwed that up. Okay, so I've made a mistake. It happens. So the solder braid's for. So solder braid goes between here, essentially one joint, and the solder. And the biggest trap that a lot of people run into is they think if they push harder, it'll work faster. That is not true. And ideally, I really want to have 2 irons to do this. It's kind of a bear to. You can do it a couple ways. You can heat the whole part up, and this is kind of abusive on the part, so I don't recommend this if you can get away with it. And that part is in there horribly. It's in, but it's really crooked. Yeah, we're gonna check that guy, because that was a pretty horrible job. So I was going to check them anyway. Now I have one that's questionable. So there you go. That's how people get themselves shot. What I just did there. I kind of overheated that part, so I actually have the risk of cracking that cap. So contacts could go bad. The cap could actually turn itself into a short. That would be extremely inconvenient. And of course then you have no idea, you know, I've had more than one case where people would go, I can't understand why my system's drawing a ton of current and there's nothing there. Why is that? And it turns out that one of the decoupling caps, which is what those 1 microfarads are, just got cracked and it shorted itself together. So yeah, it doesn't work real well then. These big guys are just such a treat. There we go. So that's it for the surface mount bits, and I'm gonna pause this and check to see how my work turned out, and then I'm gonna press on with the other side of the board. Okay, so I've gone through and I've checked to make sure my components are functioning as functioning as expected, not as corrected. So there they are, and you'll see there's a bit of shiny, crusty stuff on some of these guys, especially near the solder joints, and that's just bits of flux, and you can clean that off if you can get a small container of denatured alcohol. You can take this whole board and something like a toothbrush and just dunk it in there and soak it for a little bit, give it a quick scrub, and it'll look really nice. And it'll also get all those little bits of flux and maybe little solder bubbles, and gets all that crap off of there. And you want to do that because we have had cases where the flux actually conducts inconveniently onto adjacent pins. So I'd actually had a case where flux had gotten between 2 adjacent pins up here, and for some odd reason there was no voltage, there was no physical path that was a copper trace, and yet I was finding voltages everywhere and I couldn't explain it. And I wound up talking to a professor, and he's the one who pointed me in the right direction, and once we soaked it and cleaned it up, it worked like a champ. So now we're on to our front side, and in this case I'm going to suggest you try to do the shortest components, in other words the components that lay the closest and flattest on the board first. So I'm going to start with the 1N4004 diode, which happens to be this one, and there's also a Zener diode in here, and the easiest way to tell the Zener diode from the silicon diode is you can actually read the value on the silicon diode, and the Zener you can't. So this is where the cutters are going to come into play. So I'm going to take this little bits of paper crap off of here, and please notice the silk screen, which marks the direction of the cathode. So I need to make sure I get that little stripe in that way. And the easiest way to do everything here is to kind of test fit it and then solder a leg or a couple legs and then do a nice job on the rest and then trim it up and you're good to go. And all this diode does is just keeps you from putting voltage in backwards. Nice brute force solution for a common problem. So, and all I'm doing is I get a little bit of solder on the tip, and that'll give me good surface area contact because it's a liquid, so it'll conform to the shape of everything it touches, and then I just touch it on the other side of it, of the lead, and then let the solder flow, and that's it. And then I have a pretty decent looking joint. I could touch it up, and I think I will. And remember, it doesn't take a lot. There's an old, electronics saying that says the bigger the blob, the better the job, and is an incredibly untrue statement. It's funny, but it's not true. So there, I've got that one on there, and then I'm just going to take these side cutters and trim those leads. And you want to try and control where those wires go off to. So I'm covering it with my finger, so if it snaps up, it doesn't go in my eye, or in someone else's eye, it'll run into my finger, and that's okay. And then just get rid of the little bits of lead because I don't need them anymore. So there's the diode, that diode installed. Let's do the Zener. And this one you might want to give yourself some space so you can cut this one out, because a common thing that'll happen is if you cook the Zener, it essentially burns up into a short. So what that means is when it dies a horrible death, it becomes a dead short, and you'll draw a ton of current, and you'll never be able to figure out, why am I drawing a ton of current? And it turns out it's just the Zener is sacrificed itself in an effort to save you from yourself. Yeah, actually that works pretty nicely. There we go. And then we trim. I know I'm kind of walking all over the place with it. Okay, so another piece down. Now I'm going to go and do the capacitors that go in the crystal, or not go in the crystal, but they're essentially the caps that the crystal needs to oscillate correctly. And a lot of this involves a bit of test fitting to make sure everything lines up, and then you pull the trigger and finally solder it in place, because you can see these are, the holes are a little wider on the board than it is versus the part, so it kind of splays them out a little bit. But these two I can get away with just doing it, just placing them in here first, and they're nice and firm. And again, I want just a little bit so I can, if I have to go back and fix something here, I want enough lead that I can latch on to and make fixes instead of, totally down. There'll be plenty of opportunities to do that. And again, I'm just doing some on the tip, and the rest is just me touching solder onto the other adjacent side of the pin. And if you feel like you've got too much solder blobbed up there, because these are kind of small holes, just kind of do this, where I'm kind of taking the solder and sliding it up a little bit. It'll either climb the lead or stick to the tip of the iron. Either is acceptable. I just want to get it away from the solder joint itself. Okay. And next we'll do the crystal. Now the crystal, you probably should try to have a little bit of clearance as well. This is kind of a hard one to do because it fits so nicely. And so what you can do, because it'll lay flush if you let it, and really it's okay. If you want to give it a little bit of, you can just kind of bring it up a little, and then I can bend the leads out a touch to let it hang if I need to. I'm not sure how well this is going to work. We'll try it. It doesn't have to be perfect. Just want a little spacing. There we go. again, I need to be careful about how much heat I apply, because remember, I don't want to burn up the part. That would be inconvenient. So I need to be cautious. So there was a couple times where you saw me kind of lift the iron. Yeah, that part is hot. So I just want to take heat away, because I'm either not getting good contact and I'm just warming stuff up randomly, which isn't very effective, or I'm touching the wrong part of the board. So there we go. One more part down. Okay, now we're getting to some of the taller bits. And here is the resistor network. And you'll notice on these there's a little triangle. I don't know if you can see that in the camera. It's kind of glary. Anyway, take my word for it. There's a little triangle there, and that's the designation for pin 1. So, and if you look at the silk screen on the board, hey look, there's a pin 1. So that means that triangle goes there. And this is important because this network has a common pin, and it turns out that it's pin 1. And if you put it in backwards, it'll go through 10K. It's not what you want. Now I've got to kind of do something kludgy, because normally I would have the ability to get my hands a little closer. So what I'm going to do is I'm going to tack this pin here just enough to get it to stay put while I solder the other side. And I'm not even going to do a good job. I'm just going to get it to stay. There we go. Alright, now that it's going to stay put, I can do this right, do the remaining pins right, and then I'll fix the last one. And again, I'm going to do the same thing. I'm going to get some solder on this tip. I'm just going to touch, flow. Oh, stay put. Touch and flow. Kind of like touch and go, but different. And you can see this kind of goes pretty quick once you get the hang of it. And mind you, I'm also doing this at arm's length and blind, so if I can do that, then you can do it looking at it up close and proper. We hope. Okay. Almost there. Let's do the sockets. Okay, so here is the 40 pin socket, and you can see there's a little notch there, and just to be consistent with everything else, there is a notch there designating pin 1, hence why there's the notch and the dot that says this is pin 1. So just get that guy in there, and I'm going to do the same technique I just did on the previous part, which is I'm going to get just enough on a couple of pins to get it to stay put, and then I'm going to finish the job a little more formally. There we go. Use that to help me prop it up. There we go. All right. Also, as a suggestion, and you can see my hand jitters a bit here and there, it means I probably had too much coffee. You may want to lay off the caffeine or energy drinks before you start doing this, especially if you're not experienced, because you can get mild levels of the shakes, and it's hard to stay on a small target when your hand's busy doing this, it can be kind of annoying. I remember being told that and thinking they were crazy, and then, you know, it happens to you a couple of times and you can't hit the broadside of a barn, and you just say, oh man, I gotta just lay off the stuff for a little while and pick up again. As you can see, these go really fast once you get the hang of it. And I'm used to using even thicker solder than this. You know, I find that to be a preference thing. Depending on who you talk to, they'll say use a fine gauge solder, and I'm so used to not always having the tools that I need, I just kind of taught myself to use the solder I have. So I've got giant gauge stuff that I will use for fine pitch, and I just fake it. Not the best answer in the world, but yeah, I'm hitting 2 pins, dang it. Okay, and that socket's in. Whew. Alright, so same rules apply here. Notice the notch, match the notch up with everything else just to keep your world consistent. There's nothing wrong with that, because the more you put in to reduce the possibility of making mistakes in the long run, the better off you are. Think of it as covering your bets. So by making sure I install everything correctly before I pull the trigger means that I'm less likely to have to revisit that when it's broken. And something will go horribly wrong. It just does. Assume it's going horribly wrong and you just don't know it yet. It's part of how the troubleshooting process goes some days. Leave yourself enough hooks to get into it. Okay, and that's the socket for the RS-232 driver. Okay, now let's look at the regulator, which is the next thing. Now this one, you have to be, this is a TO220 package, and typically these pins are straight, and I've already bent them to a 90-degree angle, and you have to kind of do this a bit further up than you typically would. I wish I could get that to show up better on camera, but there's a thicker piece of the leads up here, and you actually need to make the bend up here. And when you do, and you test fit it, because you're going to want to test fit this, you want to try and line it up so that the hole on the regulator package lines up with the hole on the board. And this way you actually have the ability, you can stick a bolt through there, and now you magically can turn this hunk of copper that's on the top of the board into a heat sink, and ta-da, you have toast. So I've already test fitted it, so we'll just solder that guy in. And this one's a little tough because the center pin is ground and that tab is ground, so the heat on the, and this is where the temperature control iron really makes it easier to deal with, because that is a bear to get to a decent joint here with a dumb stick. You really have to whack it with some heat, and I'm gonna have to check that, because you want to be very careful with this, because if you have a solder bridge or something else you don't want to see happening there, you need to clean that up immediately, because you're just shorting power supplies to ground, and that's a bad thing. And I'm going to touch up the top side, because it doesn't always flow right through. Here we go. Take a quick look. Yeah, I think we're okay. And the cutters. There. Now, well, actually no, I would say continue for now. I would say I'm going to do a few more parts and I'm going to stop, and I'm going to then check out the voltage regulator, because I want to make sure it works before I move forward. The last thing you want to do is install your chips and then find out that, oh whoops, the input voltage is shorted to the output voltage or worse, and you promptly take out all your ICs. So what you want to do is you want to power this up with just really the voltage regulator. So you're checking the reverse protection diode, the regulator, and the Zener, just to make sure that nothing horrible is going on. And if it doesn't, then you're good to go. We've got the sockets all in place, and they're soldered up, and so far so good. So next step is we're going to install the capacitors. Now, occasionally I'll get the question, which side these are electrolytics, and they're polarized, which means you can't put them in backwards, otherwise you run the risk of them just blowing up. And sometimes people will ask, well, which side is positive and which side is negative? And really the answer is, look at the can and make sure. For example, in this case, these are actually marked with a little minus side on one side. So in this case, that would mean that the shorter leg is the minus. And looks like the same thing goes for this one. However, I would strongly suggest that you are careful with these things and not just say, oh, that's the short leg, then and get on with your life, because that's just an accident waiting to happen. So I'm gonna just start putting these in here, and you can see on the silk screen on the board there are little pluses marking where the polarized bits go. So while the minus is marked, the plus is marked on the board. So I need to be careful that I don't put them in backwards myself. That would be pretty embarrassing after just stressing how you need to watch what you're doing. And so I'm just going to do the ones on the one side here first, and then I'll move on to some of the other capacitors I have to install. And again, I'm going to use the same style of getting everything soldered. I had a little solder ball on there, so I'm going to wet my tip up so that there's a bit there, and then just touch and let it flow. And there's going to be a bit of a length on these as far as the top side, because I just kind of let them sit, so you can see that they're all a little funky, but it's okay. Well, looks like I got a bit of a solder ball on one of these, so I'm going to touch it up. There we go. Sorry. Okay, so that's one side done. Now you'll notice on this one, the positive side is actually on the bottom, so forgot my little exhaust fan there. There we go. So that's ready to go. Now we've got these two right here, and then since they're the same size and I have two different sizes here, I need to refer back to my silk screen, which will tell me C3 is 100 microfarads, so that's the big can, and C2 is 10, which is the small can. That's really all I need to know there. Make sure I have it oriented right before I install it. Okay. Gotta clean this up a little. Get these leaks out of the way. So, as you can see, we've got now, we're slowly but running out of parts to do, and that's not a bad thing. And when we get to the headers, which are these guys, I'm just going to do one of these just because it'll be the last thing I install. If you can see and comprehend me doing one, you don't need to see and comprehend me doing both. Just seems a little silly. Okay, so the next thing we're going to do is the DB9. It's a right angle. This is for the serial port, and this actually is kind of nice because it has these little clips that will snap into the board. So once I seat this properly, it'll stay in place. And I'll actually solder these spots, these clips as well, to give it a little mechanical stability. So when you're yanking the connector on and off, you don't take the connector with it, or you don't take this connector with it. And here all you need to do is just a little bit on each side, give it something to hold on to. Nothing major. There we go. Now let's do the pins. And while really we only use 5 of the 9 pins on the connector, you do want to solder them all, just in case you were wondering, should I solder them all? I'm not using all of the pins. You do at the very least, in the interest of keeping the connector on the board and having it something for the connector to hold on to as you insert and remove its mate. Okay. So there's that, and as you can see, it's on there pretty good. And move on to the next piece, which we'll do. Really, I'm just kind of randomly doing things now. It's just these lower level parts where you actually start running into trouble. Now here's an LED, and all its purpose in life is to just tell you that yes, you applied power and I'm turned on. Now the flat on the LEDs I have, and there is a flat there, you can't see it very well unfortunately, does match up with the silk screen. If you think otherwise, or you aren't sure and want that warm happy feeling, just quickly breadboard this up with just a 1K resistor and a power supply and you're good to go. It's a 2-minute exercise to make sure you've got the polarity right. Might as well do it right the first time, because yanking them is never easy or fun, because the hardest part is really with through hole. They're easier to solder than surface mount, but getting things cleared isn't always as easy as you like. So I could spend more time trying to get the actual solder, the plated holes cleared out than anything else, and the rest of it, you know, getting the part out's easy. I can just cut it, or I can just solder wick it and yank it out. But if the holes get filled in, then I've got to clear them so I can put the new part in, or turn it around and reinstall it correctly. So again, be careful. Oops, sorry about bumping the camera. You want to do it right the first time, because the second time will make it's much more time consuming to do it the other way around. Okay, and this is our power connector, and it has 3 pins. This one on the side you don't need, so I'm just going to take some pliers and pull this up, and essentially I'm just going to bend it until it snaps off. You don't need it. It can go away. Now the holes here, the V- and V+, that's where it goes, but it's unfortunately on the Rev 2 boards it's not a perfect fit. In fact, you have to bend the pins just a little to get it to seat and fit right. I fixed this on the Rev 3 boards, so this shouldn't be an issue for most of you, but something you need to be aware of, just so you don't act surprised and go, oh, it doesn't fit quite the way I thought it would, and run into new and interesting problems you didn't expect. And this is an easy install. Just it holds itself in place because of the tension of the pins. Touch that up just a little. There we go. Okay, almost there. Alright, now we've got our dip switch, and this goes in this way. If you squint at the silk screen, and actually it looks better on the drawing, the actual paper drawing, you can see where it says off, and so that means you want it oriented so that the little arrow that says on is, well, that if you push it up it's on, so down is off. So the little black square is saying that's the pin 1 and that needs to be in the off position. Otherwise you have other interesting, you can get around it, and it's not a critical thing. These are single pole, single throw switches, but it won't jive with anything anyone else is doing, and it might confuse you. I've seen a student install it in backwards before, and he just had to remember what he was doing when he was programming the 8051. Okay, so there are those connections done. There's the flip side of it. So we're down to, oh, I forgot a cap. How embarrassing. Not a big deal though. Like I said, this part wasn't really order specific. It was just the lower parts. So plus side is there. Minus side is there. Let's throw that guy on. And I get this one installed, and then we're down to the 4-wall headers, which is really just a way for you to breadboard stuff and attach it to your breadboard. Okay, and trim those up, and we're good to go. All right, and the last two pieces are the 4-wall headers, and this works kind of like how I was doing the IC sockets. So I'm going to hold it, preferably on a side I'm not soldering, so I'm going to hold it here and solder over on this side. So just to tack it so it'll hold still while I work on the rest of the board, provided I don't want to stick. Now if you have something along the lines of flux or a flux pen, those are very handy, and this is a case where it might actually serve you well. Okay, it's kind of there. It's there enough. Get the opposite side. So I'm now holding it somewhere else while I do this. Okay. Camera up so you can actually see that. And again, all I'm doing is touching it and letting it flow, and then taking the iron away. So just enough solder goes in, looks like it's filled the hole, and then I lift the iron up and it slides down, and so I can't see what I'm doing. Now what you really want to avoid here are two things. The first is you don't want to have exceptionally bad joints on attaching these headers. You want these to be nice solid connections. You also don't want it bridging to adjacent pins. So I don't want to bridge between this pin and the next one to it, and because essentially what you're doing is you're going to short two pins of the microcontroller together. So that's a definite avoid at all costs issue. And it really just becomes a matter of kind of getting a feel for how much solder is needed to fill in each hole. And I'm really happy how these boards turned out. Occasionally I'll get complaints, oh, this thing is hard to build, and to be perfectly honest, it's not that bad, really. If you compare it to consumer grade electronics, you'd never be able to see what you were doing, because everything would be surface mount, and most of it wouldn't even have legs. And the first try I did at this, I used even smaller components that were surface mount and more of them, and there were just so many problems and complaints that I went to larger packages and eliminated some of the surface mount components just out of necessity. There we go. And touch up. Oh, and I missed some there. Let's get him. And that was the one I tacked earlier, so I want to touch that up. There we go. Okay, I'm going to forego installing the other header because that's how you do it. What I just did, you do it again. Put it there, tack it, solder it, if I can actually get it to go there. There we go. Tack it in, hold it on the other side, tack the other end, solder each row, done. Okay, now, the other thing you have to do to make this thing function is there are jumpers. And if you read the schematic, you will see there's a couple of pads. There's actually several pads. One is for the RS-232 driver, where it takes the RS-232 signals that come from your PC and convert them to 5-volt TTL levels. And they are marked TX232 and RX232. And if you look closely, you can even see those marked on the board. What you need to do to make this thing work is you need to tie those pins to their respective pins on the microcontroller. I put these pads here so you could add a double pole, double throw switch, so you could put it in one position, program the device, so the path would then be from here through to the microcontroller. Put it in the other position, you can use those two pins as I/O that you normally would use. So you put it in the other position, and then you can talk to a device or light LEDs, whatever thrills you. So that's number one. Those are the first two jumpers. The other jumper is up here, marked JMP1. And all you have to do for this to make it work is you can tie pin 1, and if you look at the silk screen on this board, marked with a dot, and tie it to pin 2. And all that does is it completes the circuit for the reset line on the micro. So the reset is done by closing this switch and discharging this cap, or charging this cap as the case may be. And that's it. The other position, if you tied pin 2 to pin 3, lets you reset the device through some external signal that you may or may not want to use it for some future project. That was it. These jumpers are here to give you flexibility that you may or may not need, but it's there. So the other option would be cut traces, and I'll tell you that sucks if you haven't done it before, and it's just not convenient. So the solder pads give you a hook to do this task. So anyway, hopefully this was useful in terms of seeing how to do this, and thank you.